All right. Shut that. Excuse me. We'll pull these in here. Let's see. Yeah. I did that. Okay. Turn that down. Bring that closer. Check on my courses here. Okay. Good morning, everybody. So we only got a few people in the chat here. So hopefully a few more start trickling in. I think you guys can hear me okay. If you can't, my mouth is moving on the webcam right now. So hopefully someone says something. There's a few more people. Thank you. Thank you for telling me. I appreciate it very much. So today, hopefully got another kind of low-key day. We'll be introducing a new topic. which is inheritance and composition. This time, we'll just type out the notes because it's not too complicated, and the notes will not be anywhere near as long as those class notes that I had for classes. But before we do that, I'm just going to quickly introduce assignment 2 to you guys. And I'm just going to do some example runs, and I'll also walk through the code there with you a little bit. So let's get started, and let me know in the chat if you have any questions. So this is the PDF that's uploaded to Web Campus. It's the exact same one that you have. Now, this assignment I edited from the other sections. So there was an assignment that was up already. I took that down, and this one's kind of a new one. On Monday, we had the question about kind of a real-world example, and like kind of what version would we be, you know, spaghetti coding in main, or would we use classes to do something like this? And the answer is, in the real world, you're going to be using classes more often than not. And I saw a nice opportunity to make this assignment even better. So that's all I did. I made a few changes. So obviously this assignment is the exact same program as assignment 1. It's the exact same program. So most of your code you can just literally copy paste. And I kind of give you some hints here and there. So if you didn't do assignment 1, please do that. And if you're stuck, you know, just message me. I'll help you out as best I can. Sometimes, you know, if you got a seg fault going on or something, it might take me a little bit to figure out exactly what's going on, but I'll always get you there, I promise. And one more thing before I continue on with this. Some of you may still be doing this, where you're using VS Code to connect to Sally or Bobby. I think, you know, a lot of CS 135 courses last semester allowed you to do that, or even recommended that you use the SSH client here in VS Code. I think I have it here, but I may have uninstalled it. And the truth about that is, and I'm going to repeat myself because I mentioned this earlier, you should not be using the SSH on VS Code. I know it's very nice and easy for you to just save and then pull up the terminal right here down at the bottom and just run your code. But VS Code, what it does is when you connect in to Sally or Bobby, it kind of places some of its own processes on there, on those servers, to kind of, you know, help you with your IntelliSense or debugging or whatever. And it really gunks up the servers. And last semester we had a lot of problems where students couldn't connect when they had to test their programs because there was too many people just running VS Code on the servers. So if you're doing that, please stop. I mean, I can't stop you, you know, so feel free to do whatever you want. But the guys who maintain the servers will kick you off. They can see that you're doing that. And so you might start experiencing more problems than what's actually wrong with your program. Such as whenever you save your program, it might not get uploaded to Sally, and things like that. So if you're using it, I highly recommend that you stop doing that and do something like MOBA Xterm. I know it's kind of sad that you have to drag and drop every time, but that's just the way it is. And if you're on a Mac, the only thing I recommend doing is FileZilla and connecting via your terminal. And if you need help with that, I know how to do it. So let me help you with that if you need help. Okay, so now we're just going to quickly look at assignment 2. We're going to do header files, okay? Today I'll be covering how to use header files, but there's 3 total files for the assignment. You've got main.cpp, and guess what? There's nothing for you to do inside this file. And even here, if you look at it, that's it. You know, 3 lines of code. You can see up here that we include this file aisdatabase.hpp. That is one of the files that you'll be coding in. Now, nothing about your coding style will change, okay? You're just gonna fill in functions. That's it. So this should not like throw a wrench in your plans or anything. This should be straightforward and easy. As you can see here, all we do is we create a database object. Can anyone tell me what happens when we create the database object? The very first thing that happens? And then we call a member function. Exactly, constructor. Nice job. Thank you for chiming in here. Okay, so this calls a constructor, right? So as soon as we create this object, a constructor is called. So just know that, okay? That's what starts off your program. And so let's continue on looking through here. And here's the second file, aistype.hpp. This is a header file, and there are some functions in here that you have to code. Now, this class looks almost exactly like it does from assignment 1. Now, I'm going to introduce something to you now. I'm going to show you a big picture. And this picture is called a UML class diagram. In most of your assignments, I'm going to give you a UML. Okay, so whenever I say UML class diagram, it's just a big table. And the table tells you everything you need to know. Now, I know this looks scary, right? But these are the 16 rows from the vessel, right? These are the 16 rows from the vessel. MMSI, base date, time, latitude, longitude, SOG, COG, etc. Notice that they're all private variables. None of them are static. These guys can't be constant because they're variables. I mean, they can be const, but not in this sense, okay? So const on member variables is not applicable. Well, I'll have to come back to that. But in this case, the way I'm explaining to you, it's not applicable. Here are their types, and here's their names, right? And now here's our functions. And you're responsible for coding these things here in blue. Okay? Now, these are super easy. And I include these nice details. I'm not going to read this word for word. I just tried to be very detailed. But you'll notice in every single one I say can be copy-pasted from assignment 1. Can be copy-pasted from assignment 1. And then I say something like the one difference is there's no parameter object. So let's just take a look at that code. So this is aistype.hpp. Now, I gave you these. So you had to code these in the last assignment. Don't worry about it. These are already coded for you, and you don't have to do that. As well as this bool is decimal here, right? And in fact, you're not even going to call these functions. You're only going to call string convert in your code. So here's our class, right? Class AISType. It's exactly like the struct. And here's all the private variables. And then down below here in the public section, we have these functions. Now there's the void save field function. This is exactly the same one from assignment 1, except you're missing something, right? In which the original one has an AISType parameter that comes in with it, right? And it is passed by reference. But guess what? This is a function and it's a member of this class, okay? So in fact, you already have access to all these members up here, right? So you don't need this. You don't need this parameter because they're already included in the object. And whenever you're going to save a field into the object, you're going to call save field from the object. So it's going to be something like AISType, vessel. And then when you're ready, you're going to type vessel dot save field. And then you'll call it with its parameters. Does that make sense? If it doesn't, just ask questions. But this is how you're going to call it, right? This is our object, and then you're calling save field on the object. Then you have print record, exactly the same from assignment 1, except recall that this one took an AISType before. Now it doesn't, and that's because it's a member of this class. which means you have access to all these private members. So those should be very straightforward. Just copy paste them, and then you'll have to make a very small change, right? Since we're not working with a parameter, we're working with a class. Now these guys are getters. All right, these should not be hard at all. And in fact, they're constant, so you can't mess with this object in any way. Let's look here, save field. I kind of give you some comments. You'll copy paste there. Give you some comments, copy paste there. And then look, here's the getters. Every function down here is super simple. One line of code. So you're going to replace these values, right? Instead of return 0, you're going to return something here, right? I wonder what it is. Instead of returning 0 here, you're going to return something. I wonder what it is. Okay, so these are all going to be just super easy one line of code. The only reason that these are here is so that your code compiles and that you can kind of use the compiler to help you find your errors. And then down below here, I gave these functions to you. You don't even have to look at them, right? I just put this thing here, end your code, and your code here. So just keep your code between these two block comments, and that's that. So is there any questions in regards to the AIS type? Let me know. I'm going to move on here, and I'll stop if I see anything pop up in the chat. Now, the next and last file that you have to code in is the AIS database.hpp. And what is this class? This class is just going to hold all of the functions that you use to open your files, read your files, that kind of stuff. It's also going to hold these functions here: search for vessel by name, find last occurrence, find first occurrence, add unique string, and distance traveled. So all the other functions that were not in this one are now in this one. And now I kind of separate them by colors. I just like to do that because I think it looks nice. So let's talk about what you have to code. Everything that's in blue or that's in white, you have to put some code for. Except for these red ones. These red ones I gave to you. Okay, so the red ones you don't have to worry about. And all of these are copy-paste from assignment 1, except for the constructor and the destructor. And I tell you exactly what you have to do for those. So the next few pages, I just list every one, and then I pretty much state, again, what it's supposed to do. And then I kind of include this copy-paste from assignment 1, copy-paste from assignment 1. Idea. And then down here at the bottom, we have constructor, destructor. Okay, these are very easy. This one asks you to do a print statement and call a function. And then this one just does a print statement. Okay, so these are not scary at all. And that's it. So let's just look at the code. Let me zoom out here a little bit, and then I'll bring it back in. So here's the whole class. So right here, class AIS database. And you got your public and your private. So now I'm going to zoom back in. So here's the constructor. Here's the destructor. Here's this void new search. And I'm pretty sure if I just check this, you don't have to code new search. This function is basically a copy paste of main from assignment 1. So this is like main from assignment 1. Here are your variables, okay? These variables are included here in the green. Let's talk about, this is the database, right? So that's your vector of records. This is the unique string vector, okay? So notice that the unique string vector is included in this class. And then here we have this int record count. All it does is store the amount of records that we read in from the file. And then lastly, the file is going to be in here as well. So when you open the file, you can reference these variables in here instead of making some new one. And I'm pretty sure I include things like that in the PDF and in the comments. Search is the database, and then I put here in parentheses AIS data. The function will return the number of records found in AIS data. So you get it. I might have one bug here now. No, it's good. All right, so and then here's all the functions, right? So here's your code here. There's your block. Here's the constructor, right? Look, I kind of just give you the hint. Here's your destructor. Give you the hint. Search for vessel by name. I give you hints, and it says few changes here. Vector is a member of the class. Vessel name is private. Use a getter. So I'm kind of giving it to you here, right? So go ahead and copy paste in there. Find last occurrence. Go ahead, copy paste. Copy paste. Add unique string. Go ahead, copy paste. Except there's a few changes. Distance travel is copy paste, except a few changes, right? Latitude and longitude are private, so you'll have to do something about that. Open input file, copy paste. There's a few changes, right? One of them is that the file name or the file is a member of the class, so it's not passed in, right? It's present there in the class. Read file is copy paste. I said few changes here. How is save field called? What is the vector that we're using? And make sure to save the number of lines counted into a member variable. Here's getNext field. Copy paste. I think this one is exactly assignment 1. I think all of them require a few changes except for this one. I think this one is like exactly the same. Excuse me. And look, end your code. And then you're done, okay? So what do you have to do? Copy paste a bunch of stuff. And then in these additional functions that I added here, you just have to type like 1 or 2 lines of code, okay? So get help from me if you need it. There's a few more things that I'll quickly mention. Don't look at that. That's scary code. For one, I'm going to run the code. And for two, I'm going to just mention that this ais.data.csv, I uploaded a new one. This one is a little bit smaller than the other one. I think it's about 1/3 the size. So in the files on Web Campus, I include the sample output. Excuse me. So this is exactly how I ran the code. So just open this file to match. Now you'll notice that I did something like bill here. Let's see. Search for records containing bill. And it says I only found one vessel. That's different from assignment 1, right? And that's just because I shrunk that file, okay? So probably re-download this AIS data file. It's smaller than the other one. It's much smaller than the other one, though it's still pretty hefty. So we'll just do, I mean, I'm not gonna run the code because it runs exactly the exact same way as assignment 1. So if you don't know how the code runs, go find that video on YouTube. Is there anyone that's upset about that? Hopefully not. It runs exactly the same way as assignment 1. So that's that. Now, talk about the due date of that, just so you know. I gave that to you here, February 10th. So you got a week, 7 days. 7 days to copy paste a bunch of stuff. So hopefully you can do that. Or no, 6 days. It's due on February 9th, but the late deadline is February 10th. So you do have 7 days, but try to turn it in 6. Easy clap, exactly. Should be easy. And if you didn't do assignment 1, once again, tell me. Let's get it done. Let's do it together. I'm here to help you. Oh, actually, there's one thing I want to talk about. When you're running this code, you have to copy all 3 of these files in here, okay? Excuse me. I see that question there. I'll answer it 1 sec. That's a great question. But when you run this code, you have to put all the files into the directory. So I even mentioned that at the very end here. It says place 4 files in the directory. So you got to place all 4 of these files. And then here's your compile statement and here's your run statement. So that's right there for you to use. So now that I mentioned that, the question is, will we get back our assignment 1 with comments? Yes, you will. Tomorrow and Friday, I will have those graded. And here's what I'll say about that. It's a lot for me to grade. So, like I said, the comments you'll get back, it will tell you where your problem is. It won't always say exactly what the problem is. Because I got to do it efficiently. So if you can't see what the problem is yourself just from my comments, just send me a message. And, you know, chances are maybe I even made a mistake and I can get you some points back. And if not, then I'll just tell you exactly why the code went that way. And oftentimes that's easier for me because I don't have to do it for everybody. So please do that. But yes, tomorrow and Friday you'll have your assignment 1 back with some sort of comments. Absolutely. You're welcome. So now we're going to move on here, and we're going to talk about some inheritance today. So let's look at our syllabus. See what we got going on here. So yeah, we're a little like offset, right? It's like our weeks are Wednesday, Monday instead of Monday, Wednesday. But we're in week 3 here, right? So we're doing inheritance and composition. We just finished classes in this data abstraction thing. So we're starting this today. Now, if we want to go look at it in our free book, we can just copy paste that link there. And I'm going to have to search the table of contents. I'm not very, I don't think you guys are going to be using this book really because of the code that I give you. But if you need it, we'll just kind of cover this part here. Guess I'll zoom out a little bit. I know you can't see that, but I have to find it myself. There it is. Okay. So in the book here, you can see that we're talking about inheritance and polymorphism. Next week, I'll define polymorphism for you, but here's the inheritance chapter. So if you need anything about that, some nice examples, that's online, or page 495. But let's begin with that. So, I don't need these. There are a few things that I need though. For one, I guess we'll start with this vehicle thing. So today we're coding with header files, okay? So you'll get to see me use those. Here we have main, and we're talking about cars today. So if there's any vehicle people in here, maybe we can keep you engaged a little bit. I'm not a gearhead myself, but I did some Googling before class, so we should be okay. And here we are in the notes. So let's just talk about what composition is. Composition. Now this, you'll see this kind of test on, or this question on a test. Composition versus inheritance. So we call competition has a relationship. And a good example of this is a car, and then I'll put it here, has a engine. I guess I should put an N here, right? Has an engine. So that's kind of what composition means. Is this is let's do it this way. When one class includes another class. So if we had a class for cars and we had a class for engines, the class of the car, we're doing this today in the example, has an engine object inside of it. So that's what composition is. And inheritance is a little bit whack. And this is one class is derived from another class. So whenever there's inheritance, we're always dealing with a base class and a derived class. And this is a relationship. Okay. So what does that mean? One of my favorite examples of this is we can say a cat is a mammal. Yeah, CBA, that's good. Parent-child relationship. Oftentimes you'll hear parent class, child class as well. You know, just like I'm a Petrowski, right? Just like my parents. So, in a way, yes, that's what inheritance is. And so in this case, we might have a class for mammals. And what are mammals? I'm not an expert on this, but I'll just try to name a few. I think mammals are generally, well, I'll take away that, but they give life birth, right? So their children are not in eggs. I think they're warm-blooded, and stuff like that, right? So that's what a mammal is, and then all of the actual mammals would inherit from this mammal class. So before we get going with the code, we kind of have to talk about how we inherit from objects and what it looks like. I have plenty of notes here, so I just kind of want to copy them over. So I'll copy this bit. And base class is going to be, in this case, the base class is the mammal. And in this case, this is the cat. Or parent and child. So I'm going to copy this bit of code here. And we've seen this before, but we're going to keep it in this section of notes. So we're just going to talk about member access modifiers. Again, right? So we know what public is. In which the, I think we can make this even prettier. In which the public, my face is in the way here now. Which public is accessible to everybody. And private is accessible to only the class. And now we have this thing called protected. Which means if a member, a variable, or a function is protected within a class, any class that derives from this class has access to these protected members. So I would say, in a way, protected is like inherited private, in a way. So protected is more like private than it is like public. But protected is not exactly private. Does that make sense? We'll kind of do an example of that where I show you. And let's just kind of start building a class so we're not falling asleep here in the notes. So let's start with the most base class we're going to be working with, and let's do the engine. Now I'm going to kind of reference my notes here because they do keep me moving forward at a good pace. Whoops. So there's our good stuff. Notice we're in a header file here, okay? Even though we're in this header file, I'm still going to include a library. And I'm still going to use this namespace here. Now we're going to make a class. Let's call it engine. This is an engine class for a car, for a vehicle, we'll say. For vehicle. And let's say there's a few things going on in here. So for one, let's have a character array called drive. And you might prefer this. Let's not do character array. I like doing character arrays all the time, but how's this? String drive. So instead of this is going to be, is it all-wheel drive? Is it, you know, two-wheel front drive, or is it two-wheel rear drive? I know that some Jeeps and stuff can do all of this. We're not talking about those today. So we've got some driving there. We've got an integer for horsepower. Should probably put an S there before I read it again. We've got some torque going on here. I've got this Boolean value called is on. Is this engine on or off? Okay. And then we also got something like int current gear. What gear is the engine in now? And then what's its maximum gear? Okay. So that's like our engine. And all of these things should make sense a little bit, hopefully, if you've dealt with vehicles before. And notice that these are private, right? I like to be explicit with this always. So I'm going to put my private there. Now we might change this later on, in which I might want this to be protected instead. But let me show you exactly, example-wise, how this will work. So, for now, they're going to be private. And then we're going to include a few functions, okay? Let's make them kind of just pretty to start. Publix. This is not a grocery store in Florida. This is public access. And let's see a few things we need. Probably we need a constructor. Whenever we create some value, whenever we create some object, we want to call the constructor. So we'll have a constructor. Let's have some member functions. Now I said I was going to call these methods, but I keep calling them member functions, so might as well just stick with it, huh? We got our member functions here. I'm going to call this void idle. So what does idle do? It will set the engine to neutral. Right? All cars can idle without actually driving. So that's going to set our engine to neutral. Let's have a void turn on function. I think we know what that does. Let's have a void turn off function. I think we know what that does. Let's do, I don't know. I guess we'll come back to that one. And then there's one more that we'll do. We'll do void shift. I'm not sure. Let's do void shift up. This is going to be a basic engine, okay? This is going to be a basic engine. And we're only going to shift up, okay? Let's pretend that we can't go down. And we have to return the idle every time. Okay, so this is a basic car. This is like a Model T or something. Who knows? So we've got these functions. Let's go ahead and kind of code them out. So remember that we got all of these members here. So in the engine constructor, and remember this is how we do things outside of the class. If I want to put my definitions here, I have to use the scope resolution operator. In the constructor, let's always set the current gear to 0. Let's say is on, is off. How did I do it? I think it was trying to tell me there, but... So, the car won't be on, and the current gear will be false. So that looks good. Now let's do the next one. Let's talk about idling. This one's easy. We're going to set current gear to 0. So we're going to pretend that the 0th gear is the idling. That's neutral. Let's say here, the next one, we're going to turn on the engine, right? Now, I'm not including the types here, but I really should be, so that's a mistake on my end. Since the constructor is typeless, we don't have to include it there, but these are just regular functions, so we have to include their type. And in this case, we'll just say is on is equal to true, something like that. It's kind of a silly little example here, of course. And then finally, we're going to turn our engine off. And that'll be set to false. Something like that. Now, of course, we could be really in-depth here, right? I could, put an if statement in here and say if, not is on. Do something like that, right? So I want to let you know that we could be going all out here if I wanted to. But in this case, I'm not going to worry about it. So there's our engine class. So now we're going to talk about inheriting from this class, right? Because there's a bunch of different types of engines out there, right? The engine that's in your Toyota Corolla is not the same engine that's in a school bus. I think you can agree with me on that one. And so, in fact, notice how this is like the mammal example, right? All engines have some sort of drive, horsepower, and torque. Though, they're not all the same, right? Some mammals have fur, some mammals don't. I'm thinking of whales in that case. Maybe whales have fur somewhere. I'm not sure. But this is the same idea, right? So all of the engines that we'll be inheriting, they use this stuff all the time. But they use this stuff all the time too, but it's all kind of different. You know what I mean? So let's talk about inheriting. Now there's 3 ways that a new class, and let's just kind of put in our head here what engine we'll think about. So let's think about a big engine. A big engine will go in a... Let's see what a big engine does. A big engine will... Let's do this. These are going to be our engine definitions. Okay. This is going to be our engine class. And now we'll do another one. So this is where we should pay attention now, if you've been sleeping, because we've already gone over the class stuff. This is going to be the big engine class. And so we're going to call this a big engine. And now this has to inherit somehow. This has to inherit. So a big engine is an engine, right? Let's look at our notes and remind ourselves of that. It is a relationship. A big engine is an engine. So how do we inherit from that? Well, we have some syntax here. And I'll include that syntax in the notes here, but let me just type it out. We're going to put a colon. And then we're going to put some member access specifier here, such as public, protected, or private. And then we'll name the other class. Now, if I check my notes to be consistent, we're going to inherit publicly from the engine. Okay? So this is the inheritance line that happened, okay? And really, that's all we need to remember for how to inherit. That's like the only kind of new coding thing that you'll learn today is this line of code. So here we inherit from the engine class, in which the derived class is the big engine, and the base class is the engine. So now we're going to come back into our notes before I start talking about this stuff. And we're going to talk about inheritance methods. Probably thought this was pretty a while ago, but I don't think it is anymore. So I'm going to type these out. So these are member access modifiers inheritance, okay? So notice that when I'm referring to this, and let's go ahead and do the syntax while we're at it. Here you're going to have class, tab it over, class derived, and then you got this colon here, right? And then you have a member access specifier. I really don't like that. Let's do it this way. MSP is equal to member access specifier. So you have some MSP there, and then you've got your base class. And that's the syntax. Class derived, member access specifier, base. So I'm talking about these here. What's the difference between these? Peter asks, could we have nested inheritance like another class inherits from a big engine? That's absolutely 100% correct. So in C++, now this completely depends on your language. That's called multiple inheritance. I guess we'll kind of put that up here for fun. No, we'll put it down here in the bad notes. well, I won't call them bad notes, but multiple inheritance is multiple inheritance is where classes can be derived from derived classes. I gotta work on my definitions here, because also classes can inherit from multiple classes. And we'll save this. I'm glad you brought this up. We'll save this for next class. But in this kind of sense, my face is totally in the way here. When we're talking about multiple inheritance, we're talking about how classes can inherit from multiple classes. And then this thing here, I need to figure out what the term is properly. But yeah, this is just inheritance. It's just inheritance. In which classes can be derived from derived classes. Because it's just still a one-to-one. To answer your question, that's yes. But next class, we'll come back to that. Okay, so where are we now? So I'm talking about these guys, okay? So we can inherit in some different ways. And also, that's definitely in our book somewhere. I'm kind of rambling here. I'll have to come back to that next class. Inheritance is like an iceberg. It really is. So we're kind of talking about these things here. So I'll copy these over. Now, this means I'm inheriting, okay? So we're no longer talking about the members, but we're talking about the class. And so what happens when we inherit publicly? If we inherit publicly, remember that, I would like to put this in here. All derived objects have the same members as the base object. Okay, so the moment that I inherit from this engine, I'm pulling literally all of these members into the new class. So this big engine is going to have everything that's in this class. And in fact, we can add even more things to this class, which we'll do. So all of these members, which are private in engine, are going to be pulled into here. So depending on how we inherit is going to affect how we can access these objects, these members. So when we inherit publicly, public members stay public. So public members base. I think we're gonna just kind of switch this up a little bit. So public base members stay public in the derived class. Makes sense? This one is the easiest one. Protected base members stay protected. And private members, now this one is a little tricky. Private members base stay private. But I'm going to say become like super private. I'm going to use this special term. And I'll define it. This is my own term. So what I mean by super private is that all we have to do is look at the notes here, right? This says private. It's only accessible to the class. And so in a weird kind of way, since these members are all private in the engine class, this big engine class, it has these members. It has its own drive. It has its own horsepower. But not even this class can access them. Does that make sense? So that's what I mean by like super private. Is that, yes, like not even the derived class can access them, even though it has its own members. So let's go ahead and just put that somewhere. This is our syntax. And I'll do my best to clean up these notes before I upload them. I think you guys can follow it though. So what is super private? When a private member inherits into a derived object. The derived object has this member, but cannot access. Okay, so that makes sense. When a private member inherits into a derived object, the derived object has this member, but it cannot access it whatsoever. So let's talk about private inheritance here. So if we inherit privately, the public base members. Yeah, so Red Rosenrot says here, and I'll even do it in an example. If I were to do something like, and we might as well do this right now. I'm doing too many notes here, not enough examples. Here we're going to have a big engine constructor. In this big engine constructor, I can say something like you said, torque. So it actually has its own torque. I may have to use some special syntax here. But let's say we'll just start with that. There's a few things that we have to add here. So, for one, it does have a torque, but even I could even add a torque into here. And I really don't want to confuse you, so I'm not going to. But if I want to access this torque out of this class, I should use the member access specifier. So I'll say something like engine torque is equal to 0. This will not work. And we'll see the compiler error if we go take a look at it. I think this code will compile, so let's just do that. Now, this is a header file. Notice in this header file, I've included IOStream here. So if I include IOStream here again, it's going to error me out because I already did it. So the only thing I need to include here is actually engine.hpp. Using namespace std. And then in int main here, we'll just, we're not even going to do anything. I guess we could make an engine, e. But we're just going to return 0. We're not going to do anything with it. So then we'll come over here to Bobby. I think we're still alive here on Bobby. And I guess I don't need any of these things anymore. Yeah. Yeah, I know VS Code would be really nice to use in this situation. Because in MobaXterm, we have to wait for the files to upload. And we got to drag them over every time. And then we got to wait for them. But once they do, we can finally do some stuff. I'm not in the right directory, folks. Don't freak out. So look at this. It says int engine torque is private. It says int engine torque is private. So I can't even do it. So you're correct, Red Rosenrot. It's exactly... I think I said that right. Doesn't matter. So yeah, it's private. So not even this guy can access it. So that's what the super private is. This is what I mean. It has its torque, but it can't access it. So how do we fix that? Let's fix that. We, instead of doing private, we do protected. And once we do protected instead, once I save this, and then we do this whole thing again. Should compile now. Makes sense? So that's the difference between private and protected. So let's finish out these notes a little bit. So in private inheritance, public base members, what's the thing here? So they stay, and then become. So these guys become private, and it's not super private, okay? They just become private. You're welcome. So they just become, is it super private? Let's figure it out. Let's figure it out. How about that? So let's make this private. Let's see what we get. I guess I don't even need to drag over the other stuff. I can just drag over the engine. Yeah, so they just become regular private. They don't become super private. Well, man. Let's fix. No, that's right. That's right. So public base members just become private, not super private. The protected members become private. And just like this one, I'm just going to copy it. The private base members become super private. Okay? And in fact, this works always for all of these. Okay? So if there's anyone that you need to remember, it's this one. Is that this one is the same for public, private, and for protected. So in this case, I'll copy these notes. This one is pretty straightforward. Public become protected. These become protected members remain protected. So instead of become, they'll stay protected. And private members become super privates. And that's that. And so that's all the different ways that we can inherit, right? So I could do it this way, protected. And that's fine. If I don't do anything here, if I leave this blank, it defaults to private. So I guess we'll include that in the notes. We'll say if no MSP specified, default to private. So you don't always need to include this if you know it's going to be private. But like I said, I like to be explicit. So that's that. Now, let's continue on here. Let me just check the notes because I got to stay on track here. And it's definitely all over the place. So we're going to make this big engine class. But let's just start putting down some regular inheritance notes. So we talked about this multiple inheritance, and we don't even need to include this bit here. So we'll clean that up. Classes can be derived from derived classes. That's correct. What else do we say? We say that all members in the base class are present in the derived class. I showed you that, and that's why we do this protected private thing. What else do we talk about? We can override. Now, this is a new term, so let's go ahead and just put it here. Override. This is only present in inheritance. What does this mean? This means that we can override functions. Meaning base class and derived class contain a function and I guess we can even say a member, a variable. We'll stick to just function for now. Contain a function with the same name and same parameters. Does anyone want to tell me how this is different than overloading? What's the difference? This is a test question, kind of, right? What's the difference between an override and an overload? An obvious one is it's only an inheritance. Overloading can occur globally and in classes, and overriding is only an inheritance, but what's the obvious one? Because overriding and overloading both use the same name, with same name. Yeah, so Aaron got it there. Exactly. So overloading, you have to have different parameters. With an override, it has the same parameters, okay? So in overriding, for example, let's see what we can do here. We're going to override a few of these functions. Let's override this turn on function. So notice here that this engine it has this member here. So all I have to do in this big engine class is override it. So now that we've overridden it, I can do the exact same code that I would do in the normal one. For example, whoop. Except this time I'll print like a big engine noise. Let's see what my big engine noise is. We like to be immersive here. I guess I'll have to come up with one. I don't know, it can just be like, how's that? So notice how they're different. I know that I probably shouldn't have done it this way, but in the engine turn on function, it makes no noise. In this one, it does the exact same thing, except this time it makes some noise. Okay, so this is a function override. So we can do that. Let's do some more notes. In a derived class, in a derived class, we can add new members, as many as we want. So we're always welcome to do that. And inheritance is one way, right? So let's just verify this. Inheritance is one way, which means engine is a big engine is an engine, but engine is not a big engine. Does that make sense? It's like saying mammal is a cat. That's not true. Inheritance is one way. So this is very important to remember. A big engine is an engine, but an engine is not a big engine. It's not an. It's big sat. Okay, so hopefully that's making sense. We're kind of wrapping up here on the notes, I promise. I just want to make sure I get everything that we should know for this. This one's important. This one's very important. A derived constructor, I'll just say it this way. A base class constructor is always called before the derived constructor. So we'll demonstrate that for one of our for our code today while we kind of clean everything up here. Okay, so yeah, that looks like pretty much good on the notes. So a base class constructor is always called before the derived class constructor. So let's come into our notes and let's just really kind of clean this up, this code. And let me put in all the parameters and stuff that I did in my other stuff here. So for one, in this engine constructor, we're going to put a cout statement, and we're going to say constructing engine. Okay. And then I'm just going to include all of this stuff. I know that this was kind of a disgusting way to do this, so we're just going to fix that. So this way, the engines with the engine and the big engines with the big engine. We're not going to add anything here in this private section for now. In the big engine, we're going to set some things, right? So I did some Googling, and I think that some of this stuff will make sense. And since... I know I'm being confusing here. Since I said that we could include our own torque member, this is an array, like an override. If we did that, we would want to specify which one we're talking about. But since this is a protected member and it's no longer super private, we can just do this instead. So we can say that our torque is equal to 1500. Let's say our max gear goes up to 12. Let's say that our horsepower is equal to 500. And that looks like we'll do our big engine. And then let's go ahead and say that the drive is all-wheel drive. And when we turn it on, it'll make this nice fun noise. Now we're going to copy these and make just 2 more engines real quick, and then we'll run some stuff in main. So instead of a big engine, we're also going to have a passenger engine, meaning like this is your Toyota Corolla. I see a question here. I'm sorry, I kind of covered up the chat. Can you access the inherited class from the base class? The answer to that is no, you cannot. And the way to think about that is, no, it's a good question. You should always ask questions. And the thing to think about it is this way: an engine is not a big engine, so you can't access anything big engine inside engine because engine is not a big engine. Did I say enough engines there? I hope I did. But yeah, so that's correct. It is one way. That's exactly what that means. So on our passenger engine, let's kind of fix this stuff, okay? So I want to just inherit publicly because I want the public things to stay public. I want the protected things to stay protected. Right, because I want to be able to access these functions from main. So we'll inherit publicly in the big engine. We'll inherit publicly in the passenger engine. This passenger engine is going to be a little smaller. And then there's one thing I wanted to do here as well. I wanted to say that cout creating big engine. So this is just going to help us see which constructors are being called in which order. And this is important, I guess. I just kind of thought about this myself, just like in my head, but not the same for overwriting. So we're going to be calling this function turn on. And if we call turn on from the big engine, it's also not going to call this turn on function. It's going to call either one or the other. Constructors are different though. So let me just kind of put in some fun little things here. Big engine, passenger engine. So we're going to do 5. This the maximum gears in this guy can be 5. The torque on this is going to be only 130. And the horsepower on this is only going to be 150. And I think we do 2-wheel forward in passenger cars. 2-wheel forward, that makes sense. And this can just go like a something like that. And then we'll make one more class. This is passenger. If I can get my clicks right. Like I'm playing World of Warcraft here or something. Big engine. Actions per APM, right? Actions per minute. Not World of Warcraft. StarCraft. That's what that's from. Don't roast me. This is going to be a sports engine. So in this sports engine one, it's just, you know, a little bit different. Max gear will be 6. Our horsepower will be 400. The torque on this will be 460. And this will be 2-wheel rear. That's how sports cars normally are, pretty sure. 2-wheel rear. Ugh, 2-wheel rear. And this can be like, I don't know what's a good one. It can be like a loud vroom or something, okay? So let's go ahead and fix our constructor. Let's see out our constructing statement, and then let's run it in main, and then we'll just kind of wrap it up for today. I know we were a little bit all over the place, but I think we had a good class here. So sports engine being constructed. And that should be ever good. And so we've got this override for the turn on all of them. There's the passenger engine, there's the big engine, and there's our regular engine. So we'll just keep it there for now. We're going to make an engine E. We're going to make a big engine BE. We're going to make a sports engine SE, and we'll make a passenger engine PE. And so as we create these, we'll just see out some lines because I want to easily tell where our print statements are. And then we'll turn them all on just to show you. turn on. These are public members, right? And because we inherited publicly, every public member is going to be inherited as public. And in fact, though, these turn on functions are overridden, so that doesn't matter what I just said. SE, and then PE. And then we can do this. Check this out. We can actually turn them all off at the end. But remember that I didn't override that in the other functions, right? I only overrode the turn on function. I'm going to call turn off from the other functions. Did I do my shift up function? No, I didn't. We'll have to come back to that next class. So I'll be able to call turn off from all of these objects. And nothing will print out, unfortunately. But we can change that. And in here, we'll just go, we'll find our turn off function, and we'll do a nice print statement because those are always fun. It's how we make coding fun. That's also how we find our errors. So we're going to see out something, and it's just going to be like, I don't know what cars make when they turn off. They just go like, and then sputters and something like that. Okay. So let's bring this on to Bobby here. It looks like I'm doing that today. We also got to bring in main. Got to see if everything compiles. And we'll run our code, and then I'll just do my closing statements. In the next class, we'll talk more and more about inheritance. We're going to finish up this example. What did I do here? Turn off is inaccessible to main. It says, well, let's figure it out. Big engine, public engine. Look the issue here, okay? So what does this default to? This is defaulting to private, right? So in the sports engine, it inherits privately. And if we check our notes, whenever we inherit privately, public base members become private, protected base members become private, and private base members become super private. And so if we come up and look in here, in our public here, we've got this void turn off function, in which down in here, I forgot to specify something. So it defaults to private. So turn off becomes private. And then I try to access it from main, and it says, hey, this is inaccessible. So how do I fix that? I gotta put public here. And it's fixed. And now everything will compile. Should. I just have to bring the engine class in. Yep, and then we'll ./a.out that. And let's look at all of our code side by side. Might be a little hard to see here. Maybe I just zoom out a little bit. We can put on our reading glasses or something. So if we're looking in main, first we create an engine, right? So that's what this line of code here is. The very top, it says constructing engine. And then we see out this little line here. And then, look, we construct this big engine. And what did I say in the notes? I said that a base class constructor is always called before the derived constructor. Always. Always, always, always. So notice that we construct an engine first, in which when we construct that engine, we initialize current gear to 0 and we turn everything off. And then it calls the big engine, in which it initializes the remaining members of that class. And you can see that it's called there. Then we construct a sports engine. You can see the exact same thing that happened here, in which we construct an engine first, and then the sports engine is being constructed. It seems the passenger engine, we made some mistake here. Oh, I just didn't do a cout statement. We're not going to worry about recompiling it, but I will upload it like this. Okay. So I forgot to put a cout statement there, but notice that we did construct a passenger engine, so it called that base constructor. And then this one definitely got called. We just didn't print anything. And then notice here that they're all engines, and I call this function here, turn on, which happens to be overridden. This one doesn't make any noise, but these three all make different noises. And then I call turn off from all of the engines. And notice that these are not overridden by any of our derived classes. And so they all default to the base class here, which is here, the base class one. And you can see that they all kind of make this noise when the engine turns off. So that's it for inheritance today. Are there any questions about what I covered? Some of you guys were asking really good questions in which, like, I couldn't even get there in time. You know what I mean? So next class, we're going to talk more about inheritance because there's so much more that we have to talk about. But just in terms of the basic stuff we covered today, if you've got any questions, let me know. I'm going to clean up these notes a little bit before I upload them. But yeah, remember this stuff, has a and is a. We haven't done composition yet in the example. That comes next class when we introduce our vehicle. And then I may do another example. If you're still here, here's a great example of this. I know a lot of you probably play video games. So if you ever play Overwatch, or you play World of Warcraft or League of Legends, inheritance in objects is exactly how these things are coded. In which you have something like a player class, which all players have a base amount of health, and they have a base amount of mana, and they have a move speed and stuff like that. But then when you start creating these new characters like Mercy, I guess, from Overwatch versus Reinhardt, they have different amounts of health, they have different move speeds, they have different abilities. In League of Legends, you could consider something like Ashe or Yorick. Those guys have different healths, they have different move speeds. But all of these players inherit from one superclass, from one base class. So this is exactly how to think about inheritance. And so it's very common, and it's a very cool tool that we're going to be using. So that's that. Office hours are in 15 minutes. You're free to go. Thanks for coming to the stream today. It's always a highlight to see you guys in the chat. and ask questions about the assignment if you need. And I'm done. You're welcome. You're welcome, you're welcome. All right, I'm going to cut the stream now. Come to office hours if you need me. And there it go. Oh, hold on. We got a question. I'm not cutting the stream yet. We got a question. Hopefully you're still there. In VS Code, you can hold Alt and click or double click on the names, let go of Alt and type. This will make it so whatever you type will be... Oh. Let me try that. Maybe you can help me with this. So you're saying if I hold Alt and I double click this, and then I let go, and if I type like new, I messed that up, huh? It's not working. Let me see. So I hold, oh, that's Control. I'm silly. I hold Alt. I click it. Let go of Alt and... So shouldn't it work with this too? So if I think that's what you're saying, right? You can hold Alt. Maybe my VS Code is broken. So I see that it's highlighted there. And then if I type, ooh. Okay. Oh my gosh, I spelled, no, it's good. Oh. Oh, did it? What? What? I'm so sorry. I'm not seeing this. Okay, this is fun. I got it. Let's do it. Let's do it. Okay, so click here and click here. And then... Yo, that's so cool. Thank you. Oh, and look, we got it even in here, too. It's like... I did it, right? I succeeded? Let me do it again. Oh, look. Oh, wait. No, that's good. Yeah, I succeeded. We did it. All right, guys. I'll see you in office hours, or I'll see you on Monday. Thanks for coming to the stream. And thank you for that knowledge here in my garage.